started watching YouTube and fiddling around, and I need something to wash the prints, and I need something to cure the print. I better order one of those as well, and it just sort of grew from there. And much like yourselves, I was like, I wonder if this is going to work. And you do your first print, you go, oh shit, that actually wasn't as hard as I thought it was going to be. And then next one thing led to another, and then I bought another printer, and then I bought another printer, and now I've got my current printer it's an 8K printer, and when you hear people talking about 2K, 4K, 8K, it's just the resolution of the screen, right? Because in all of these, I'm not talking about filament printers. Filament printers are the ones with the you've seen them and they print. People use those for like architectural type models. They're like big, a print size this. I mean, my printer, which is an Elegoo Saturn 2, which is an 8K printer, it's got a 10-inch build plate, so it's about that big. So that's how much you can fit on it, right? And like you can print things that are that tall, but in terms of actual footage of you being able to put stuff on it, when you're a 48 scale and 32nd scale modeler, that's a lot of stuff you can cram. And if you can't fit it all onto one, then you just do a second print. It's not like you own the printer, you can do as much as you want. So yeah, and really all I wanted to do this time around was just step you guys through the three. You reckon Pete's live streaming? I don't have no way of knowing. Anyway, let's assume he is. Anyway, so my name's Gary Wickham. I've been modelling, probably like most of you, ever since I was in primary school. And then I joined the Air Force and modelling stopped for 20 years. And then, I don't know, one day after I'd left the Air Force and I got a job with IBM, and I thought, I'd like to be doing more than just sitting around, drinking beer and whatever on the weekends. And I go, I wonder if I've got any of my old modelling stuff, So I dug through the boxes and found like ancient Humbrol tins of paint, and I mean, at this stage, like, I was cashed up compared to when I was a kid. So, and I was in Newcastle because I was still in the Air Force, and I went to Frontline Hobbies when they were still in Hunter Street, and bought an airbrush, an old Pash, single action airbrush with the diaphragm compressor, and and then I bought the Revell Mirage, and anyway, so this, I got back into the hobby, and I kind of haven't stopped ever since, right? So I love it. It's kind of my main passion, and I mainly build aircraft. But this year I got roped into building a tank, so it's actually on the table down there. There's a bunch of us that do a group build for each show. We do one for Illawarra, we do one for Canberra. This year it was a Dragon Sherman tank. So anyway, so I broadened out a little bit. Are we good? Okay. And if you're interested in any of my stuff, I've got a website which I've maintained. So that's kind of call that my portfolio. So anyway. So today we're going to talk a little bit about 3D design and printing 101 for scale modelers, right? So I'm not an expert in CAD, I'm not an expert in 3D printing. I'm much like you guys, I'm just 2 steps ahead of you. That's about it, right? So I'm not going to have all the answers. If you ask a really tricky question about how do I do this now, let me figure it out. Let me check on YouTube, right? So, but all I really wanted to do was just demystify what is in 3D printing and what can you use it for and what can't you use it for, and maybe you'll feel a little bit more confident to take that step. So, because even a top-end printer, right? As I said, my printer's a couple of years old now, and since the Saturn 2 came out, there's now been a Saturn 3, there's a Saturn 4, Saturn 4 Ultra, which are now 12K printers and so forth. And even if you pay retail price, you're looking at $700. Right? So yes, you think, oh, that's expensive, but you go down there and buy an eye-wider compressor and an airbrush, you're not going to get any change from $700, right? So if you think of it in that perspective, and hopefully what this will show you is this just opens up a whole new world. If you love scratch building with copper wire and plastic card and all that sort of stuff, the way I approach this is it's like it gives you the opportunity to digital scratch build, right? Rather than using your hands to do stuff like you would normally. You could design it digitally, and then you can print it, and then you go, oh, well, I've just designed a new set of wheels for a 48 scale Skyhawk. But I've got a whole bunch of 32nd scale Skyhawks. Well, you don't have to reinvent it, you just scale it up and print it, right? It's because there is no scale in the computer. It's infinitely scalable, right? So same with things that you download, you purchase or you download for free, set of Skyhawk wheels, and they say, oh, 48 scale. It's like, well, that's fine, I want them in 72nd, you scale them down, print it, right? So that is what, to me, is one of the real benefits of this technology, especially now that more and more manufacturers and more people are making things available to purchase digitally. And I'll give you an example in a second of one where basically it really just proved my point, because a lot of people say, I'd rather buy the physical thing and blah, blah, blah. And I'm like, yeah, okay, well, that's fine, but, I'll give you an example when we get to that point. But in terms of the 3 basic steps, and you could break this into a more complicated diagram, but I thought, what are the 3 basic steps? First is you need to acquire a model, an object, a 3D object, right? And you can call it a file, you can call it whatever you want, but it's basically a 3D object. And the 3 ways that I acquire things for my models, I either download a free one, and there are literally hundreds of thousands of 3D models available on the internet that you can download for free. Now, out of those hundreds of thousands, it'd be like a very small percentage that are for our hobby, right? But you'd be amazed. Like that Sherman I was just telling you about, it was a Dragon Sherman, and like all the jerry cans were like 2 parts, you had to put them together to stand the seam. The smoke dispensers, which I've learned were kind of unique to the Israeli Shermans, on the side of the turret. Dragon had 2 halves and you would put them together, you got to sand it. It's like, oh my God. Some guy had already designed them in 3D and he uploaded them for free, and I went, thank you very much. 1/35 scale, printed them out and just used them, right? So, but I also wanted a nicer 50 cal for the top of the turret. I paid $14 Australian for this amazing 3D print of a 50 cal. Separate barrels, separate ammo basket, ammo container closed, ammo, like a draped, belt of 50 cal ammo, like it's just stunning, and that cost me $14. Now, if I want to scale that up to 1/24 scale, I want to scale it down to 1/48 for something else, then once I bought it, I own it. I own the rights. Now, I can't go and sell that. Right? I can't print it and then sell it and make a profit, because that's not what the license allows me to do. But I can use it for my own purposes as much as I want. So you can download free objects. You can buy, because there are plenty of online marketplaces, and you've probably heard people talk about places like CG Trader, Cults 3D. There's a bunch of them, right? Very reputable. I just use PayPal. Go in there, create an account, and you just buy it. And then once you've bought it, the other good thing about it is if the designer or the creator of that object, say in 2 months' time, they go back and they go, oh, I found a problem, I've corrected it. Well, you still own the rights, so you just download it again, right? You always own the rights to that once you bought it. And then the third way to obtain an object for you to print is you design it yourself, right? And now think of it as Mount Everest. I'm at base camp at the moment, right? So I'm not at the foot of the mountain. I've dipped my toe in the water with 3D modelling software, designing my own stuff, and I'll show you how it works. Just so, again, it's like demystifying it, and it hasn't cost me a cent. I haven't had to spend 1 red cent on the software, because the piece of software that I use is a piece of software called Autodesk Fusion 360, which is actually like for professional 3D modelling, but they have what they call a hobbyist license, which costs nothing. As long as you're not selling the output for you're not making more than $1,000 US a year, right? Then it's free. It's called Fusion 360 for personal use, right? And that's what I've got. So again, this you can once you've laid out for the initial capital purchase of the printer, and the resin and the other bits and pieces. Once you're set up, then it doesn't need to cost you a lot of money, right? So then the second stage, and we'll go through each of these, is you've then got to prepare that object for printing, right? So first of all, you've got to get yourself a 3D file or design or whatever it is you want to print. If you're into ships, then you can get whatever things and whatever. Then we prepare it for printing, and then we actually send it to the printer, right? And yes, there are all different types, all different brands of printers, and Elegoo and Anycubic and Frozen and blah, 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 blah. But they all pretty much work on the same principle, right? And I'm not going to go into depth about how a 3D printer works and so forth and so on. if you're really interested, then come up and grab me afterwards. But I'll show you actually the steps so you can follow the bouncing ball and see how I created these. We're gonna take this object and we're going to design it from scratch. We're going to then prepare it for printing, then we're going to print it, and that's the output, right? Until I did this object didn't exist anywhere in the world, right? So it's a simple thing, but hopefully it will show you give you the idea of what's involved. Does that make sense? Okay, excellent. All right, so, and again, I'm happy to make this slide deck available as a PDF to anybody afterwards, so don't feel like you've got to, copy all these URLs down and whatever. But the first thing was, how do I download a free object, right? Well, there are literally millions of 3D files freely available on the internet. Some of them are like, crap. Some of them are really good. But, there are plenty of places, and these are just some examples of websites that actually offer, they focus on free 3D print files. So Thingiverse, Printables, Cults, Maker World, My Mini Factory, if you're into Warhammer and that sort of stuff. The list goes on, right? And even the commercial marketplaces, people can go on there. Like I've got an account on Cults, and I can upload my designs and say, well, I don't want to charge anything. They're free, right? So you don't have to charge, but most people sort of go. Like I found one the other day where it was like, it's $4.50 plus. And it's like, oh, okay, so I can pay more than $4.50 if I think it's worth it. And so I just went, I'll give you $5. Like it's kind of that community sort of thing. Sorry?
Buy me a cup of coffee approach.
Exactly, that's right, yeah. So if you think you're getting the value out of it, then I was more than happy to pay $5 for it, right? So free is a good place to start. And then if you go, well, I can't find what I want for free, then you can basically say, okay, well, maybe I can find it. Somebody has done, and quite often what you'll find is, like I was looking the other day for somebody, they said, oh, can you print me some GBU 12s, like laser guided bombs? And I said, oh, yeah, let me have a look. And I found a couple of free ones, and they were pretty basic, and they were all like one object. Because what you'll find is a lot of things where you say, oh, I want a GBU 12 or I want a Mark 82 bomb or whatever, and you'll find them and like the guys designed it digitally and it's just all one thing. And that's where you've got to start experience once you get into it and you go, you know what, that's going to be a major pain in the neck to print, right? Because yes, it looks great in the computer because it's a non-physical, it's a virtual object in the computer world, right? But the 3D printer translates that into the real world where you've got things like gravity. You have to think about when you're printing, the resin, if it's very thin, will actually distort as you're printing it into a physical object, right? It has to be supported, whereas in the computer, there are no constraints. It can be anything. It can be as complex as you want. When you move into the real world, you've got to think about, oh, well, all of those spark plug leads that I put onto my, R2800 engine, all of a sudden, those things, when I try to print them, they just sag and they don't work. So I've got to put supports, so there's a bit of stuff that you need to learn, converting it from a digital object into a physical object. But to me, that's that's all part of the interest in learning a new tool. Some of the best ones that I found the best quality and ones that are relevant to our hobby, whether it be armour or aeroplanes or whatever it might be. Cults 3D is definitely the best one. That's where I would start looking. CG Trader, I've also bought a bunch of stuff from there. Gambody is not really depending on what part of the hobby. If you're like a fantasy figure, like you're into, but I bought a bunch of stuff from there. Things like Imperial probe droids out of Star Wars. The droids that, the Sentinels out of the Matrix. The squiddies with the tentacles and whatever. Gambody has all of those 3D ready to print. They're like a kit. Like you buy it and then you get like all these downloads, and that's for one's for the tentacle, one's for the body, and you assemble it like a kit. You print them all out, and then they interlock with each other. And when they have sales on, they have like 40% sales off like every other week, right? So that's also a really good one. Like Nostromo out of Alien or like you name it, the Terminator and all that sort of stuff. So if that's your thing, then Gambody is definitely like you probably want to avoid that because you'll go broke. Right? And the models that that you buy, the digital models are like super detailed, like they're really worth,
and what's the finish like? Do you have to sand them or anything, or are they good straight to go?
No, not at all. My godson is heavily into a computer game called StarCraft, and there's a bunch of figures. Like there's one of the characters in there is called Kerrigan, the Queen of Blades, and so she's like this. She was a human, and then she got converted into some sort of, and she looks like she's got all these big wings and whatever. And I bought it for him, and I printed it. It's like a 120mm figure, the torso, the legs, and whatever. And like I can show you some photos afterwards. It is stunning, right? If you bought that in a shop, you went and bought it, at B&A or something, it'd be like a $150 kit. I think I bought it online when it was on special for like $20. And I can print out as many as I want. I can scale it up, I can scale it down, I can do whatever I want to it, right? So, yeah, Gambody is like really top notch. But you're not going to find, Thunderbolt wheels, or you're not going to find, that's where you'd go to Colts or CG Trader and hope that somebody else, like I found a guy that must have built the ICM Stearman, 32nd scale Stearman. He'd done a full engine, did all the wheels, did the seats, and each one of those was like $5, right? So, there's more and more, as more and more of us get into it, right, and we learn and we start designing stuff, and you upload it, then that's all it is. A lot of these guys are not full-time 3D designers. They're just people like us who have gotten into it, designed it for their model, and then gone, oh, I can make a few bucks if I put that on Colt. No, I don't need to ask $50 for it. I just ask for $5 for it. If I sell 10 of them, then I've made $50. The other thing that I've noticed is a new trend with model manufacturers. So like Armour Hobby, I'm sure you've all heard of Armour Hobby. They've actually recently on their website. So I recently bought their new Aerocobra, P39 Aerocobra in 48 scale. And in the box came a little piece of paper, and it said, thank you so much for buying our Aerocobra. If you've got a 3D printer and you'd like to print at home, then here's a voucher, a code to go and download for free a new set of 3D, like a seat with harnesses, etc., right? And so I went, oh, okay, that's good. And then, of course, once you get there, then it's like, oh, there's all these, right? So it was very clever advertising, but like that's the one that I got for free. But if I had to pay for it, it was €2. Now, I'm not sure what the current conversion rate is for euros, but let's say it's double. That's $5, right? And I can show you some photographs of these seats. They are as good as anything Edward would put out, right? Or ResKit, right? They are stunning. And if you've got a good printer and you know how to print it, then, you can just pump them out. Not that I intend to build an army of P39 Aerocobras, but, I've still got a couple of Hasegawa ones there that would fit. And you can see here that they even come pre-supported, completely ready to print. You buy it, you download the file, you put it in your slicer, you slice it, and you send it to the printer. Done, right? So, you don't have to go through a lot of mucking around and preparing it, no, that didn't work and this didn't work and whatever, right? So even the manufacturers are now coming up with, you can see here 3D files. You look at their menu. So you could buy that if you didn't have a 3D printer, you could buy the physical thing. But these guys are in the Ukraine, I think it is, or Poland or somewhere, right? Poland, yeah. Right. So yes, you could buy it, and then you'd have to pay the shipping, and then you'd have to wait for it, right? This is an example. The other day I was talking, as I said before, I've become a very big advocate of, the whole digital download, not matters of size. Bloody hell. Oh dear, oh dear.
What have you been researching? These bloody algorithms.
Yeah, well, I know what Facebook ads are going to be giving me now. Okay. I must... mattersofscale.com. Anyway, my story was I'm working on the new Magic Factory A4M Skyhawk. And I was fiddling around let's say it was a Tuesday night, and I was ready to go to bed, and I was working on the wheels. And it's like, oh my God, this is a new tool kit, and they put bloody rubber wheels, vinyl wheels in there. It's like, I thought we'd gotten over that. right, years ago with Trumpeter and whatever. But no, they put it in there. I went, I've got a spare Hasegawa Skyhawk downstairs. I'll get that and I'll just pinch the wheels out of it because I'm gonna put it on a pole anyway, so I won't need the undercarriage. Did that. Next morning I got up, checked my phone while I'm having breakfast. Oh, shit, Matters of Scale. John from Matters of Scale has designed a new 3D replacement for the Magic Factory wheels with the tyres and the whole thing, right? With both types of threads that the Skyhook, tread that the Skyhook used. And I'm like, oh, okay, how much is it? Oh, $7 US. Bought it on my phone, downloaded it, went upstairs after breakfast, went on my computer, prepared it, put it on the USB stick, plugged it into the printer, and by 9:30 it was printing, it was ready by lunchtime, and I had new wheels, right? Now, compare that to, I've got to hope that Matters of Scale sells it to B&A, and then B&A gets it in the next 6 months, and then I've got to order it before all of you order it, and I'd miss out. Or I've got to order it from him directly because he's in the US or Canada, and pay the shipping and so forth and so on. So 9 o'clock in the morning when I had my Weet-Bix, I didn't have wheels. By lunchtime, I had 3D printed wheels that were spectacular, right? So to me, it's like, you want things straight away, like digital downloads and digital supply is the way of the future, in my opinion, right? And so people like Armour Hobby they're kind of waking up to that, and they're basically making it available. All right. So anyway, so there's that GBU 12 I was telling you about. See the price? $13.91 Australian, right? So these bombs, they're in 148 scale. You can see 148 GBU 12. Scale really means nothing, right? You can pretty much ignore scale. Because as I'll show you, it's so easy to scale it up yourself with no loss of definition, no loss of quality, no loss of resolution whatsoever, right? So, but I think when they post these, and this is on Colts, right? I bought it, downloaded it. The chap that was, talking to me said, "Oh, I want it in 32nd scale." I went, "Okay, right here." So I scaled it up to 32nd scale, and I printed him a bunch, and I think it cost me something like 30 cents worth of resin, right? Because yes, people go, "Oh, but the resin's so expensive." Well, you buy a 1 kilo bottle, it's like $55 or $60, right? You can buy more expensive stuff, you can buy less expensive stuff, but I've found that through experience that the $60 ones are about it's the sweet spot for, I'm not getting ripped off, but I'm not getting shitty resin that's going to fail on me, right? So that's kind of, where, and I buy all my resin off Amazon or eBay, but you can see this guy here, who knows what other things he's got lurking, right? He's called Brew It Man, he's got 11 designs, right? So you go and click on that, and you go, oh wow, he's done Mark 82s, and he's done this, and he's done something else, right? So yeah, to me, it's basically the future. So that's how you might obtain a 3D object. Now, the last thing, which I'm actually going to show you, is if all else fails, and you've got something really specific that nobody else has ever made, and you're never going to find it, and you want to dip your toe in the water with designing a 3D object, then this is kind of where you end up. It's like, I need to build it myself. It'd be like the same as, well, QuickBoost haven't done it, Aries have not done it, ResKit haven't done it, I'm going to have to scratch build it, right? Think of this as digital scratch building, right? And that's really all it is, right? And there's plenty of different types of modelling software that are available. Some of them are open source, free, some of them are, tens of thousands of dollars. Fusion 360 is, like, if you paid a commercial license for that, it's like, I think it's something like $700 a year, right? Correct me if I'm wrong, but I think Autodesk are the same people that make Photoshop, right? So no, that's Adobe. Adobe makes Photoshop. Anyway, so this is used by manufacturing firms and so forth, right? But the moment I learned that there was the for personal use version, I thought, okay, well, if I'm going to learn 3D modelling, then why not learn a package that I'm not going to run out of puff with? Because a lot of people buy or download the open source, the freeware stuff, like really easy, you just drag things and drop, and then they get to the point where they go, okay, well, I've mastered that pretty quickly, now I want to do something more complicated. It's like, well, it's run out of puff. You're going to have to, I didn't want to have to learn 3 or 4 packages. I wanted to just cut to the chase, bite the bullet, get in and basically learn this one, right? So you can see here, this is the for personal use license. It's limited free edition that includes basic functionality for qualifying users. Now they say basic functionality, but when I go in there and show you the tool, you'll go, oh my God, if that's basic, I'm you know, I'll eat a ham sandwich. Like it's you know, I've not even come close to, you know, there are things in there that I've not even looked at, right? So, but you know, so to me, this was the obvious thing. And the other thing is that the more you get into it, you start getting into communities on Facebook and on the internet of other modelers who do 3D modelling, and they were all using Fusion 360. All right, so that to me it was a bit of a no-brainer. So we've talked a little bit on the left-hand side. How do we get a 3D model? Then we prepare it, printing, and so forth. So what I'm going to do now is I'm going to focus on this box here, design a 3D object. And we're going to do a live demo, the Fusion 360 and Chitubox. And Chitubox, we'll get to that in a second. That's the slicing software, right? The thing that we're going to design is a radiator for a phalanx, 1/35 scale phalanx. Because I can't remember even what the brand name is now, but there's beautiful, the injection molded plastic with photo etch and so forth, and metal barrels, 1/35 scale phalanx. And initially I thought, oh, it doesn't come with a one-piece cooling radiator for the end of the barrel there. So I thought, oh, you know what, that doesn't look very complicated. I'm pretty sure I could design that in 3D and print it. And then of course, as soon as I did that, I had a better look at the box, and there's a metal radiator in the box. But you know, I didn't think it was a waste of time because I learnt stuff, and it's the perfect thing for this workshop. All right, so that's what we're going to do. Let's assume we've looked on Colts, we've looked everywhere. No one's ever done this. We're going to have to design it ourselves. All right, so I'm already in Fusion 360, and this is a three-dimensional workspace. So think of two-dimensional is like I'm writing on a piece of paper. Three-dimensional is I've got three axes, right? So this is what's called my origin. So I've got my X and Y axis and my Z axis, all right? So X and Y and Z. So Z is vertical height, all right? So that's our three dimensions. And the basic premise, without going into too much detail, is that the way Fusion 360 works, it's called a parametric 3D modelling tool. And so everything is constrained to within a series of parameters, and that'll become more obvious when I start doing stuff. So the first thing you do is we want to start with a sketch, and a sketch is a two-dimensional, like I'm drawing on a piece of paper, right? Not even 3 dimensions, right? So what I do is I go up here and I say I want to create a new sketch. Can you guys see that? Okay. Yeah. So, and it's even really helpful, like for numbies like me that go, oh, so what does that mean? Oh, we create a sketch and blah blah blah. So I'm going to go into sketch mode, and it says, oh, okay, well, which plane, which 2 dimensions do you want to sketch on? Do you want to sketch on this 2 dimensions, or that 2 dimensions, or that one, right? And so what I have to do is I have to use my origin and pick, see as I move over each of those things, it highlights. So I'll say I'm going to pick the YX plane, all right? And you'll see it's created a new sketch, all right? And what I want to sketch is, remember, essentially this is just a cylinder with a bunch of holes in it, all right? So I'm going to create a circle to start with. So I go back up here and say, create a circle. Now there's many different ways in this tool that you can create a circle. You can create a circle based on 2 points. You can create a circle based on 3 points. You can create a circle based on a center point. So I'm going to select the origin there, right? And I've created a circle. Yeah, big deal, okay? And I'm now going to finish that sketch. So now I've got a 2-dimensional circle sitting in 3-dimensional space, right? It has no depth, right? It's just a 2-dimensional circle. Now what I want to do is I want to turn that into a solid body, right? So the terms that I'm talking here, and if you look over here, you'll see that there are things, sketches, and then we'll have bodies, and we'll have components, and a bunch of other things, right? But what I'm going to do is I'm going to take that, and I'm going to say, I want to extrude that circle into a cylinder, right? Because a cylinder is a 3-dimensional object. So I click on the button here, and it says, okay, I assume that the thing that you want to extrude is that circle because it's the only thing in your sketch. If I had multiple things in my sketch, I'd have to pick the one I wanted to extrude. And all you do is you just drag that and you go, oh, okay, so how long do I want to make that? And I'm not doing the full dimensions things here, right? What I can do is I can say I want to make it exactly 35 millimeters. I can even have a taper, but we're not going to get into all of that, right? And then over the left here, you can see, do I want to do a solid extrude? Because you can see there that this is like a solid piece of, if I click on here, this is called a thin extrude. And so now you can see it's like a pipe, is actually put a hole in the middle for me. And here I can specify the wall thickness and so forth, right? So there's a lot of what looks intimidating, but it's actually quite common sense, quite straightforward, all right? I want to create a new body because I'm creating a new three-dimensional body here. We'll leave it at 1 millimeter and I'll click OK. And now, if I rotate in 3 dimensions, you can see I've now got the starting of my radiator, right? All I really need to do now is put the cooling holes in it. And you think, okay, so those holes need to go down the side and all the way around, right? Because they're all symmetric. So how do I put a hole in that body? Well, the first thing I need to do is I need to create another sketch. So I created one sketch in 1 dimension for the circle, but now what I want to do is I want to put a sketch along the side of this cylinder, right? And it doesn't really matter where. So what I'm going to do, the way that 3D modelling works, is for me to be able to create a sketch, I need to have a reference plane. Now we always start with the standard 3 planes, right? X, Y, Y, Z, blah, blah, blah. But you can create your own planes in space, in 3-dimensional space. So what I do is I come up here to the construct menu and I say construct a tangent plane. Well, that sounds useful because I can create a tangent on a cylinder, right? You can do ones in the mid plane, you can do planes at an angle, right? So I say tangent plane, and then it says, well, what, a tangent to what? So I have to select the face and see how when I hover over the cylinder, it highlights the outside of the cylinder. And now you can see it's actually created that plane for me, right? So the orange square is a new 2-dimensional plane which is tangential to my cylinder body. And I might say, well, I don't want it at 0 degrees. I actually want to move it around to somewhere else, depending on what you want to do. But in this case, 0 degrees is actually perfect for what I want. So I'll put it back to 0, press enter. And now, this is what they call, it's not part of the 3D model, it's just part of the superstructure, or the architect, the framework around it to allow me to do things. So now I've got that construction plane, I can actually do a sketch on that construction space. So I can select it and then say create new sketch, and it says okay. And you see it rotate the object. So now I'm back in 2 dimensions. And I'm sorry if I've lost you, but hopefully you're keeping up. And now what I want to do is I want to create a hole for the circles, for the cooling holes. So I'm going to create another circle, and I'm going to come over here and say, yep, let's make it 10 millimeters. Sounds good. No, that's too big. Let's make it 6 millimeters. All right. Press enter, and I go, oh, that's okay. I still don't have a hole because all I've done is I've sketched a circle on that plane, right? But what I want to do, and this is where the parametric side of Fusion 360 comes into it, because this is all well and good, but what happens if I get to the end of it and I go, I want to go back and change that to be a 5.5 millimeter hole. I've done some prototyping, I've tested it, I did a print, I want to go back and, right? Because when you're creating your own stuff, you're going to want to go back and do multiple versions, right, to get it right. Well, this is where the parameters come into it. And the other thing about 3D space is that to have a fully constrained model, things have to be constrained. And you'll see up here, there's this whole section called constraints. So I'm not going to use any of that at the moment. What I want to do is I want to come back here, and I want to, where are we? No, where's the sketch? Where's this? Oh, here we go, sketch. What I want to do is I want to basically put a sketch dimension. Because at the moment, I have no idea how far that hole is from the end of the cylinder, right? At some point, I might want to change that, okay? So what I want to do is I want to put a constraint, a sketch dimension. So I click on the center of the circle, I click on the edge, and now, come down here, I can go, I want to make that exactly 5.5 millimeters. You see it move? The circle moved. And that is fully constrained, right? It's never going to, I can't grab that circle now and just drag it, right? It's been constrained. And there are lots of constraints. To do 3D modeling properly in Fusion 360, you need to learn how to use constraints, and that's one of the biggest things. So you can say, these 2 points need to always be coincident. In other words, if you move one point, the other one moves with it. They have to stay together. This one is, it always has to be horizontal or vertical. So if you grab one tip of a line and you move it, it doesn't go like that. The whole thing stays horizontal because you put a constraint on it to say it always has to be horizontal, right? So I'm not going to get into too much detail, but what I've done here is I've made sure that this circle will always be 5.5 millimeters away from the edge of my cylinder. So once I've done that, it's like, okay, so now I've got my cylinder, I've got the circle. Who wants to take a guess at what I'm going to do to cut a hole? I'm just going to do another extrude, yeah? So here I'm just going to say extrude, just like we extruded the main body. I'm going to extrude it, and it's not going to go out, I'm going to go in. And see how you got that red bit? That's because the operation here is a cut. And it's smart enough to know that the chances are 99% that I'm going to want to cut a hole. Now I can say, no, I don't want to cut a hole, I want to join. Right? I actually want to have that like sticking out. What if I wanted it to come in and out? Well, then I could change the direction to be symmetric. So now it's doing 2 millimeters in both directions. Right? So this is where it takes you time to learn all the tools, that are available in think of that as like your palette of designing. But in this case, it actually guessed perfectly correctly that I wanted to cut, in this case, a hole in the other body, and I click OK, and now we've got our first hole. All right. So
if you drag that across to the other side, would that cut the same hole, or is that another sketch you've got to make?
What I want to do, So at the moment I can't move that because remember I constrained. If I wanted to move that hole, so let me just explore that. Let's go back and say I want to move that hole into the middle. So I go back and I edit the sketch, so it goes back into sketch mode, and I go, I want to make this 25 millimeters. So now it's pushed it, right? Yeah. And I say finish sketch. Well, everything after that is the extrusion and everything, because if you look down the bottom here, you probably haven't noticed, but there's a timeline. Right. Another thing of parametric model is you've got this timeline of all the steps that you've done. And so what I can do is see it's got like a play thing here. I can go back to the start. This is how we started, and I press play, and it goes, okay, the first thing you do is create a sketch, then you extrude it, then you create a plane, right? So basically, you can move backwards and forwards through the timeline at any point and say, I want to experiment, what if I did this, what if I did that, right? So at any point, I can go back. So the way it works is that any changes that you make to something at this point earlier in the timeline will flow through. It basically propagates, which is exactly the way you want it to work, right? So that's, the timeline is really convenient when you start coming back and fiddling and go, oh, I put that in the wrong spot, and and that's why you need to make things so that they're not just sort of randomly plonked on top. They actually are connected so that as things change, parameters change, everything adjusts automatically, right? So I'm just going to put that back where it was. Otherwise get out of it. I'm just double clicking on the sketch, put that back to, what do I have it at, 5.5. Finish the sketch, and there's my hole. And now what I want to do is I basically want to get a row of holes that go all the way down. Now I could go and draw more holes, and I could extrude them, but there are, like most of these things, there are smarter ways to do that. There's this thing called a rectangular pattern. So I basically click on rectangular pattern, and it says, okay, so do you want to have a rectangular pattern in straight lines, up and down? Or do you want it to be in a circle? Or do you want it to follow a random line? Well, in this case, I just want a bunch of holes that are evenly spaced along the side there to create my first row of holes. And so what it allows me to do is I can select the objects that I want to create a pattern for, and see how it turns blue, right? And then I say, what axes do I want it to be? Well, I want it to run along that axis, right? So I highlight the green line, and then it goes, okay, that's good. How many do you want? Well, I want 3 or 4, or however many you want. So 5 is too many, they're overlapping. Let's go with 4, okay? You can see it draws it for me. I can basically create multiple axes, but for what we want, this is perfect, right? Click OK, and it's duplicated that feature, that hole, 4 times. I go, oh, that's good. So now what I really want to do is I want to now create another pattern which takes those around the surface of the cylinder. So then I just go back and say, okay, well, I want to create another pattern. This time it's a circular pattern. And I say, so what objects do you want? So I want to do that one. I want to do that one. I want to do that one and that one. What axes Well, the axis that I want to use is actually the surface of the cylinder, right? Not a X, Y, or Z axis. I want to use the surface of the cylinder. So you click on it and it goes, okay, that's fine. How many do you want? And you can see it's already started to mark it out because it always defaults to 3. So it equally spaces them. And I go, oh no, I think, how about 5? That looks pretty good. And I click OK, and we're
That's
done.
cool.
Okay? And that took literally 1, 2, 3, 4, 5, 6, 7 commands in Fusion 360. Now, admittedly, that is a simple design, but I think you'll agree that that's not. I know I can see from your faces you all followed that, right? That's not beyond you. You're not looking at that going, oh my God, I could never master that, right? So if you were worried about, oh my God, how would I ever do this? How could I ever cross that hurdle? That's how easy it can be, right? And there's the one I prepared earlier. This is the first one that I tried to do for serious because the float plane down there that I built, it didn't have a boarding ladder, and of course it's a Halberd Models kit, it's a full resin kit. Nobody else in the world has ever designed a boarding ladder for it. So I'm like, well, if I want to do it, I've either got to scratch build it out of plastic card or I've got to design it in 3D. And so that's what I did. I basically just learned, and you can see that's got a few more steps in it, but if I go right back to the start and just play through the timeline, this gives you an idea of I drew it, put the first bar in, put the thing. Really all I'm doing is I'm doing exactly the same thing I would do if I was scratch building it out of plastic card, I'm just doing it digitally, right? How did I learn how to use Fusion 360? Well, YouTube is your friend, right? There's this guy, and there's plenty of them on there, but I would highly recommend this guy. It's called Product Design Online, and it's literally learn Fusion 360 in 30 days, from start to finish, right? And so far I've only got through, well you can see I've only got up to day 8. And from day 8 I was able to design everything I've wanted to be able to design yet. I've still got a lot to learn, a hell of a lot to learn, right? But it's, to me, I've now got the confidence to be able to, give something a go. And there are plenty of really knowledgeable people and helpful people on the internet, Facebook and so forth, that are willing to help you. Well, that's certainly been my experience. Okay, so let's go back over here. So that's all well and good. We've created a 3D design, but now let's turn it into a 3D object, a 3D print. So Fusion 360 makes that pretty easy. So I just go up here and say, 3D print. Oh, that was pretty interesting, pretty easy. And all that's going to do is it's going to take that 3D model and export it in a file format that's compatible with my 3D printer. That's all it is, right? Because I might have created that 3D design and it's going to be used in a computer game. It never needs to be printed. It's never going to exist in the real world. But in this case, I do want it to exist in the real world. So I'm going to export it as an STL file. And I have to select the object. So I'm just going to go back over here to the timeline and say I want everything. So it selects the whole thing. Because if I just selected one of those holes accidentally, that's all it would export. I just get one hole, right? It's like, well, no, that's not what I want. So I click OK, and then it says, well, where do you want to put it? Let's call it a 20 millimeter radiator. And I'm just going to store it in my downloads folder on my computer. Fusion 360 has like online, cloud-based, storage and all that sort of stuff. But when you want to print something on your printer, then you just want to save it. Save to my computer, right? So save, and now if I go on down, look at my downloads folder. Here it is. There it is. I've just exported it, and if I double-click on it, there it is, right? That is exactly the same as if I went and bought something off Colts or I downloaded it off Thingiverse. It's a 3D object. It's an STL file. If your friends say, oh, can I get a copy of that 20 millimeter radiator that you designed, you just email them that file, right? And then they can do the rest.
Because you made that at 20 by 35, at what point do you fix the dimensions for printing?
So that's the next step. So at the moment, we have a three-dimensional object that's just sitting in three-dimensional space, right? Now what we want to do is we want to prepare it for printing. And so for that, we need a piece of software which is called a slicer. Now there are many different slicers. These are all free. This is all free, all right? So there are a couple of main ones that most people use. There's one called Chitubox, which don't ask me what that means. And the other one is called Lychee, as in the fruit, Lychee. And they have a free version, and of course they have a pro version, which you pay a subscription for. I've never ever needed the pro version. Everything I want to do, I can basically do with the free version. And the first thing that you need to do is when you get yourself a new printer and you download the slicing software, is you need to set up your printer and the resin that you'll be using, because each resin has different parameters, different properties, different exposure time and so forth. And you can see this is very simple. I've got a Saturn II printer, and this is all about the printer here. And they have built-in profiles. So if I go in and say I want to add a new printer, it'll let me pick off a list, right? So they've done it all. And then it says, tell me about the resin that you're using. Oh, well, I'm using a resin that has an exposure time of 2.5 seconds. And again, this looks intimidating, but all the resin manufacturers provide all this stuff on their websites. You go, I've got a Saturn II printer, I'm using Elegoo, I'm using Soraya Tech, Fast Navy Grey. On a Saturn II, it goes, oh, okay, well, you use an exposure time of 2.5 seconds, you'll do this, you'll do that, right? And it fills it all in for you. They have profiles, right? So, and with the new modern printers, you don't have to worry about any of this stuff, right? It's getting much more plug and play. Like you just put it in and you just print, right? You don't have to worry about any of this stuff, right? So once I've selected my printer and my resin that I want to use for this particular print, the first thing I need to do is this represents my build plate. So that's literally what my build plate on my Saturn II looks like, right? They've even, if I selected a different brand of printer, it would change that picture. Like it's very user friendly. So at the moment, that's just an empty build plate. So what I need to do is I need to say, well, what do I want to print? Well, remember I downloaded my STL. So I go in and say open. So it opens it and boop, there it is. It's now sitting on my build plate. But that's not really optimized for 3D printing. You think, well, but it's on the build plate, and when the print starts printing, would it print? It'll probably kind of print, right? But what you really want to do is, and this is where the experience comes into it, and learning and experimenting, is I could print it that way, or what I know from experience is if I take that and let's make 2 copies of it. All right, so now I've got 3 things that I can print using the same design. And what I want to do now is I want to rotate one of them in one dimension. So now I'm going to make that 90 degrees. So I've just made it upright. Okay. This one, maybe it'll be better if I just make it 45 degrees. All right. So again, all I'm doing here is I'm just fiddling and experimenting with these objects and saying, I wonder which one would actually give me the best print results. Right. It's a bit of trial and error. And so all of these are perfectly valid, but what I know is that, can you imagine that if we try to print that, it's got nothing supporting it, right? So as soon as we try to print it, the only thing that's holding that onto the build plate is like this microscopic edge here. And don't forget, 3D printers it's upside down. So that build plate is actually the prints, because they get built up in the printer layer by layer, but it's all upside down. So what's going to happen is that the only thing holding that 3D print as it grows, as it builds, is that tiny little edge, and you've got gravity pulling against it as it builds and as it goes up. So I know for a fact that would fail miserably, like it just would not work. That one might work because it's got the whole edge of the cylinder, right, on the build plate. That might be enough to hold it. And this one would probably almost certainly fail as well, because you can see it's got a very small footprint. So the slicing software allows me to also then say, okay, well, that's good. Take this one and I want to generate some supports. And what you do is you say, okay, to start with, and I do it all the time, you use the auto supports. There's an auto support button here, you say auto supports, and it calculates and it goes, okay, we think to get this to print, these are the supports that you're going to need, right? Because these are the parts that are going to fail due to gravity, due to printing forces and so forth. So you can see it's created all of those supports for you. You might say, well, I know from experience, I want to put another support here, I want to put another support there, etc. And so the software is really quite clever, and it really doesn't. Most people can get this up and running very, very quickly. What about this one? This one here, let's see what it reckons. Let's do an auto support. So it's like, oh, okay, there's 1 million supports. What about this one? 45 degrees. Let's do auto supports for that one as well. And you can see that it's basically said, okay, well, I need to put a bunch along the bottom here to keep it, so that it will print. And so now these parts are now ready for printing, all right? Some parts that you'll buy, like those GBU 12s. Let's just go back over here for a second. Where are we? Where did I buy it from? Colts. You can see I buy all sorts of things. I buy or I download them. No? Oh, I know. GBU 12. So let's bring in the GBU 12 body. Let's see. GBU body coated. Okay. Now remember that was a 1/48 scale GBU 12. You can see that it's already supported. The guy that created it, I don't have to do anything. I don't have to do anything. That's ready to go, ready to print. But what if I wanted it? I said before, the guy that I was doing it for, he said I wanted it in 30-second scale. That's 1/48. No, I said no. So what I can do here, so far we've seen we can move things on the plate, we can rotate them, but we can also scale them. And so here I go, okay, so, what's the scaling factor from 1/48 to 1/32? Well, I happen to have over here a spreadsheet, which I found on some website somewhere. It's called a scale calculator. So all I do is I say, okay, I want to, what's the percentage that I need to use to scale from 1/48 to 1/32? Oh, 150%. See where the two, 1/32, 1/48. So I need to scale it up by 150%. Come back over to the slicer and I say, I want to lock the ratio. So if I change the percentage ratio in one dimension, it'll scale linearly or equally. So I just put in 150%. And now I've got a 30-second scale. Boom. All right. What if I wanted to do a 30-second scale and a 1/48 scale? Well, I just make a copy, make 2 copies, and I say I'm going to scale that one back down to 1/48, or I just return it to 100%. Right? And so on and so on. Right? So, you can create as many as you want, then you can fill up the build plate, because if you're going to print, like I never ever print just one thing, because you might get a print failure, you might get, right? If you're going to print, and as I say, the slicer software will actually even tell you how much the resin you're going to use in milliliters and how much it would cost you, right? The other thing I can do is I can just come up here and say auto layout. I want to lay out all of these parts on the build plate based on so it tidies everything up for me, right? It's all nice and good, ready to go. And then I just say slice. And you go, well, why is it called a slicer? Well, the way 3D printers works is it prints in layers. So what it does is it takes the 3D object and it slices it like a loaf of bread. Now for this particular print, it needs 997 slices, because I told it that I wanted each layer in the Z-axis, the vertical axis, to be 50 microns, right? So 0.05 millimeters each layer. And you'll see here, if I use the little drag bar here, if I go back over here for a second. So have a look at each of the objects, and as I pull this down, see how it's showing you how it's slicing it? And each of those is a layer that the printer will print, and then it'll move the build plate, and then put it back down, then it'll print the next one. So it's additive, it's just building it up layer by layer, all right? So you can see here that as I go, each one is like adding, and it's just showing you. And then once I get to the top, the very tallest print is the last thing to print, right? So that's why it's called a slicer, because it's slicing whatever you want to print into layers. Once I'm ready to go, I just say slice, I slice it, and then I say save. And it says, and in my case, my printer, I can't send it via Wi-Fi. I just have to put it on a USB stick, and I take it over to the printer, plug it into the printer, and then we'll swap back over to my presentation here. So this was, I took some screenshots just in case this didn't work. This is the front LCD panel on my printer. I plug the USB stick in, I click the print button. It then comes up with a list of all of the files, the print files on my USB stick. And you can see there, the one in red, they're my phalanx. And I go, yep, that's the one I want, touch screen, boop. And then it says, are you sure this is the one? Yes, the one I want. I press the red circle to print, and then away it goes. And to print these guys here, and you come up and I'll hand these around, it took me, when I took this photo, it had been printing for 17 minutes, and it had an hour and 13 to go, 1.5 hours. Now that's what I would call a medium resolution print, not a high resolution print. If I was to set that at high resolution mode, it would probably double the amount of print time, because each layer is thinner, and therefore you need a lot more layers, all right?
So that last point where you had 997 layers, if you said I want high res, it might do 1800 layers.
That's right, or more.
And the other question, when you print one thing, or the 10, it's not quicker to print one. It takes just as amount of time to print 10 as it does.
That's
one.
right.
So that's why I say
That's right.
print as many as you can at once. Because
Exactly. I never ever just print one because it's not going to save me any time.
Right.
Right. So, and people are tempted to say, well, you know, why would I print it vertically when it's if I print it sideways, then it's less layers, so it's going to be quicker. Yeah. Well, I'll show you why in a second. And so this is a photo of the print after it finished. So this is me. I had my camera, and that's the build plate. Remember how I told you it, because it dips into the resin vat, and it prints upside down, right? So that's, and you can still see all of the liquid. See the pooling of the liquid resin here, right? So it's covered in liquid resin. I then put it in the wash, and it's washed all of that liquid resin off. So now you can see the prints are clean. And then you use literally like a paint scraper, and you scrape the parts off separate them from the build plate, and then you put them in the curing machine because it's ultraviolet sensitive, right? And then this was the end result. So these are all the prints. And I actually had a couple of failures. You'll notice that I had 3 of everything. 3, I scaled it up. I had 2 print failures on the actual 1/35 scale one. The ones that were at 45 degrees all printed fine, and the ones that were horizontal all printed fine. These are the vertical ones, and they actually are dimensionally very accurate. There's no distortion, no, bowing of the circle or anything like that. The ones at 45 degrees also printed pretty well. The reason I wouldn't go with that is because there's a lot more things to clean up, right? You've got to cut those supports, and then you've got to sand it and so forth. Whereas this one, all I've got to do is cut a bunch off the end and then just give it a wipe with a sanding stick and I'm done, right? The horizontal ones, yeah, they printed, but look at the shape of them, right? They've got this big bow in the middle, like a big belly. And even though the photos here don't show it, if you held them up, when they first printed, they were like an egg. They weren't even circular, right? So, yes, it would work, and this all comes down to experience. The more you do it, the more you fiddle around with it, and you go, oh, well, that didn't work very well. The next time I'll print it at 45 degrees or print it at 30 degrees or whatever it might be, right? So it's all about finding the compromise between getting the right print but having the minimum amount of supports. Because the more supports you got, the more cleanup you've got to do, right?
Theoretically, how many objects could you put on there? Is there constrained like how close they are?
Nope. No, you can literally have them touching. It doesn't matter. Yeah, so you can pack your build plate to the foot. You can fill it to the gunnels, right? So, I mean, there are other things that the more you get, like suction forces, because it has when it prints the layer, then it's got to peel it away from the bottom of the vat and so forth. So that all comes into it, but for the most part, there's no reason why you couldn't fill up your build plate, and people do. Like they maximise every print, especially if it's like a 6-hour print. Like you want to get maximum bang for your buck. So I know my time's up. I hope that helped and didn't confuse or intimidate you even more. But if you want to have a look, you come up and have a look at the actual prints that were generated. Yeah, I'll be around if you've got any questions or whatever, then yeah, come and hit me up. Thank you, Chair.
Oh, they're good.
So that's the 135th scale one.
You can continue, but I've got to cut the live stream.
Yeah, sure. You go for it.
Yeah, they're good quality, aren't they?
Yes, I'm on our YouTube channel.
Yeah, I was going to say,
That's
they're
what
all
you can actually
eBay
use,
Gary.
Sorry?
What's the sense on your model?
No, because I ended up finding in the box there was a metal one, so I didn't really need. I didn't need the 3D printed one. So, but it was a good exercise.
I do have a question.
Two questions.
Yep.
As a straight out beginning process, how effective is you putting stuff on windowsill and using the sun and UV light?
That works.
Yeah.
The other thing you can do, I see a lot of people buying off eBay for like $10, like the fingernail. Yeah. So if you're only doing like tiny little things like that, then that's fine.
Yeah.
Right. You don't need a $400 bloody thing that, because I mean mine is like really big and it's got a plate that goes around and whatever.